Good day, students. My name is Siri, and today I'll be taking you physics, and the topic we'll be looking at is mechanics. So get your writing materials and your calculators, and we'll be right back. Welcome back. Okay, diving straight into the topics. As we know, we'll be treating mechanics, and we know that mechanics is simply a branch of physics that deals with the study of motion, forces, and energy. So mechanics has to do with motion, forces, and energy. And why do we study mechanics? What is the importance of this mechanics? Mechanics is crucial in understanding natural phenomena, designing machines, and solving real-world problems. So mechanics has brought about our ability to study and solve real-world problems as it's applicable to man. So what are the branches of mechanics? The first branch of mechanics is kinematics. Kinematics. What is kinematics? It is simply the study of motion without considering the forces that what cause the motion. That is what? Kinematics. And then we have what? Dynamics. Dynamics is the study of the forces that cause the motion. So when a body is in motion, there are forces that are responsible for that motion, and that is what we call dynamics. And then the last branch of mechanics is statics. Static is simply the study of objects at rest or in equilibrium. Okay, so what then is motion? What is motion? Motion is simply a fundamental concept in physics that describes the change in the position of an object over time. So the change in the position of an object over time is simply what? Motion. And motion was brought about by great scientists like Sir Isaac Newton that developed the work of a prominent scientist, Sir Galileo Galilei, who first worked on motion. So also, it is a universal phenomenon that what governs the behavior of objects in the universe, from the smallest subatomic particles down to the largest galaxies. So when we talk about motion, it has to do with a whole lot of aspects of what? Human natural phenomenon. Okay, what are the types of motion? So I categorize motion into two broad types or forms based on certain parameters. The first type of motion is based on path. Based on the path of an object, motion can be classified into four. And what are these four categories or types of motion based on path? The first one is translational motion. Translational motion is simply motion in which an object moves from one point to another on a straight line. On a straight line, we call it what? Translational motion. And then number two, we have rotational motion. This is a type of motion in which an object moves around a fixed point. So when an object moves around a fixed point, we call it rotational motion. And then we also have oscillatory motion. Oscillatory motion, this is a type of motion in which an object moves to and fro about a fixed point. When an object moves to and fro about a fixed point, we call it oscillatory motion. And then we have circular motion. This is a type of motion in which an object moves in a circular path. So when an object moves in a circular path about a fixed point, we call it circular motion. Each one of these motions are phenomenon that we can see in our day-to-day activities. Like in the first one, translational motion, you can see it in a bike moving from one point to another on a straight road. They also have your oscillatory motion. You can see it in a pendulum bulb that is being what? Lifted during a physics experiment. Then you can also see your rotational motion in your fans. Your fans are moving about a fixed point, so they are rotating. And then you can see your circular motion in a cyclist doing its race along a circular path. So we also have types of motion based on velocity. So based on velocity of an object, we have what is called uniform motion. Uniform motion is simply motion with constant velocity. This is a type of motion in which the velocity of the object does not change. Then we also have non-uniform velocity. This is a type of motion in which a body that is moving constantly changes its velocity. So we also have accelerated motion. This is a type of motion in which a body moves at regular intervals with a particular speed or increase in the displacement of the body. So moving on, we have certain parameters that describe motion. So if you want to describe motion, there are certain parameters that must be in your description of motion. One of such parameters is displacement. Displacement is one of the parameters we use for what? Describing or explaining motion. So what is displacement? Displacement is simply the change in the position of an object at a particular period of time in a particular direction. Displacement is simply the change in the position of an object at a particular period of time in a particular direction, and it is measured in meters, and it is also a vector quantity. Then we have the next one, which is what? Distance. This is the total length of path traveled by an object, and it is a scalar quantity. This is the length of path traveled by an object, and it is a scalar quantity. It is also measured in meters. And then we have speed. This is simply the rate of change of distance with respect to time. The rate of change of distance with respect to time, and it is measured in meter per seconds. And because distance is a scalar quantity, automatically also makes speed a scalar quantity. And then the next one is velocity. Velocity is the next parameter. Velocity is simply the rate of change of displacement with respect to time. The rate of change of displacement with respect to time. And it is a vector quantity. Why? Because it contains displacement, which is also a vector quantity. And it is measured in meter per seconds. It is measured in meter per seconds. The next parameter is acceleration. Acceleration is simply the rate of change of velocity with respect to time. The rate of change of velocity with respect to time. It is also a vector quantity. Why? It contains velocity, which is also a vector quantity, and it is measured in meter per second square. It is measured in meter per second square. Okay, we also have the graphical analysis of motion. And under the graphical analysis of motion, we have the displacement time graph, we have the velocity time graph, and we have the acceleration time graph. Each one of these graphs are used to represent motion. So if I have my graph like this, I have time here in seconds, I have displacement here in meters. So my displacement time graph is a straight line graph. It is a straight line graph. So it will take longer time to get to a larger distance or a larger displacement. So as the displacement is increasing, the time taken to get to that point will also be what? Increasing. The same also goes for your velocity time graph. So in your velocity time graph, I have velocity here measured in meter per seconds, and I have my time here measured in seconds. So your velocity time graph combines this. If I have something like this, so this is my velocity time graph. My velocity time graph. So on this velocity time graph here, you can see that I have the velocity at different points. So as I'm having my velocity here, this is my starting point here. So this is what I call the initial velocity. the initial velocity at this point, and I have it moving uniformly. So at this point, this is what we call what? Uniform velocity at this point. And at this point, we have the acceleration of the body, and here we have another uniform velocity, and then we have deceleration. So all of these are your graphical representation of motion. So let me quickly explain that we have also two types of velocity. We have two types of velocity. We have the final velocity and the initial velocity. We have the final velocity and the initial velocity. The initial velocity is the starting point of an object, and the final velocity is the end point of an object. So that takes us to what we call the equations of motion. The equations of motion came into existence from the parameters that we originally talked about that we use for describing motion. Okay, moving on, we have the equations of motion. The equations of motion were derived by Sir Isaac Newton in order to be able to solve questions relating to motion of a body under normal circumstances. And the equations of motion are categorized into equation of motion under constant acceleration. So when a body is moving, we are going to describe it using the way the body is moving to be able to determine the parameters to solve the question. And here we have the first part, which is what? Equation of motion under constant acceleration. Now, the equations of motion under constant acceleration are based on the previous parameters that we've used for describing a body that is in motion. I remember I talked about displacement, I talked about distance, I talked about acceleration, and we have also related all of these to time. So the equations of motion here were derived by Sir Isaac Newton based on these parameters. And the first parameter that we talked about, like we said earlier, we talked about velocity, we talked about acceleration. And according to Sir Isaac Newton, or from the parameters that we have talked about earlier, we said that acceleration is velocity over time. Because we said that what acceleration is the rate of change of velocity. And we already established previously that velocity is of two types. We have the initial velocity and the final velocity. So if my acceleration is simply change in velocity over time, or the rate of change of velocity, which means I have change in velocity over time. And since my change in velocity is equals to final velocity minus initial velocity, automatically it means that my acceleration A is equal to final velocity minus initial velocity all over time. From this parameter, if I cross multiply here at this point, automatically I'll be having final velocity minus initial velocity is equals to acceleration times time. So if I move my u to the other side, it means that my final velocity is equals to u plus at. So this is my equation 1 for equations of motion. Moving on to equation 2, Sir Isaac Newton also said that the average speed of a body is distance over time. Average speed or average velocity is simply distance over time. You can also say this is displacement over time. So if that is the case, our average velocity is equals to distance. We represent distance with s over time. And if that's what I have, my average velocity, from what we already established before, we said that we have two types of velocity, which is initial velocity and final velocity. This can also mean that my distance is average velocity times time. And we know that our velocity is of two types. So we have initial and final velocity. So automatically it means that my distance is initial velocity plus final velocity divided by 2 times time. Why are we dividing by 2? Because we said what? Average. So the average of two things is simply addition of the two things and dividing by 2. So it means that my distance is equals to u plus v divided by 2 bracket t. This is my equation 2. Moving on, we are moving to equation number 3. Our equation 3 was derived from equation 2. So from our equation 2, we established that the distance of an object is equal to the initial velocity plus the final velocity divided by 2 times time. And if you recall, from our equation 1, we said that the final velocity is equal to initial velocity plus acceleration times time. So if I substitute for my final velocity in our equation 2 here, it simply means that my distance will be equal to initial velocity plus my final velocity here will become what? U plus 80. This is divided by 2 bracket time. So at the end of the day, I have my distance to be equal to 2u plus 80 divided by 2 in bracket t. And that will give me that my distance is equal to 2u over 2 plus 80 over 2 bracket t. So 2 will cancel out 2 here, and that would mean that I have my distance to be equals to u plus 80 over 2 in bracket t, and that would mean that my distance is equals to ut plus 80 squared over 2, which is simply saying that my distance is ut plus 1 over 2 at squared. This is my equation 3. So moving on to equation 4. Our equation 4 was derived from equation 2. So from equation 2, we can tell that our distance is equals to u plus v divided by 2 in bracket t. And we recall that we said earlier that v is equals to u plus at. So this can simply say that if I make t so the formula, I'll be having v minus u is equals to 80, meaning that my t is equals to v minus u over a. So if I sub t to be equals to this into our equation 2, it means that my distance will be equals to u plus v over 2 bracket v minus u over a. If I open this bracket, it means that my distance is equals to uv minus u squared plus v squared minus uv divided by 2a. Okay, so this is what I have. So moving on from there, I still have, it means that my distance here, if you look at this, I have what? uv, and I also have minus uv here. So they will cancel out themselves. So automatically I'll be having minus u squared plus v squared divided by 2a. If I cross multiply, I'll be having v squared minus u squared is equals to 2as. If I move u squared to the other side, it means that my v squared is equals to u squared plus 2as. This is my equation 4. So there's the fourth equation of motion. So these are the equations of motion. Then we have equations of motion under uniform circular motion. Under uniform circular motion, your equations of motion are simplified such that my velocity is equals to 2 pi r over the period, and my acceleration is velocity square over the radius of the circular path. And that is how you solve questions based on circular motion. So that takes us to worked examples. So we're going to look at some examples on what we have been doing and how this is applied in our calculation. So come with me. The first question here says an object moves with a constant velocity of 5 meters per second for 4 seconds, then accelerates uniformly to 10 meters per second in 2 seconds, and finally moves with a constant velocity of 10 meters per second for 3 seconds. Sketch the velocity time graph for this motion and calculate the total distance traveled by the object. So the first question here is based on velocity time graph. And for you to solve a question on velocity time graph, the first thing, you must know how to sketch out the diagram. You must sketch a graph of the motion. So the first thing we are going to do here is to sketch out the graph of the motion. So this is my graph. So I have velocity here in meter per seconds, and I have time in seconds. So from the question it said the object moves with a constant velocity, which is the same as saying uniform velocity. So it's starting with a uniform velocity of 5 meter per second. So this is 5. Starting, this is 0, the 0 point, and this is 5 meter per second. And the time it took for it to move this is 4 seconds. So I'll trace this down, and this is 4 seconds. And from there, it accelerates uniformly. So it accelerates from here for 2 seconds. So it accelerates and got to a point here. So I have another point here. This is 10 meter per second. So it got to 10 meter per second in 2 seconds. So 2 seconds plus the initial 4 seconds will give me a total time of 6 seconds. And then from there, it moves with uniform velocity or constant velocity of 10 meter per second. So at this point, it continued the motion for another 3 seconds. So it continued this motion for another 3 seconds. So I'll trace this down. So if I add 3 seconds to my initial 6 seconds, that will give me 9 seconds. So this is my velocity time graph. This is a sketch of the graph. So the next question said calculate the total distance traveled. So we have to calculate the total distance traveled based on this sketch. And for you to solve a question on velocity time graph, you need knowledge of your equations of motion, and you need your mathematical knowledge or prowess in place as well. So if we want to solve this question, we have to break out our diagram into different forms in which it contains. So if you look at this diagram, you discover that I have here the first box here. So I have the first box here, in which this part is 5, and then here is 4. So in this first box here, that's what I have. I have what? 5 and 4. And then I have another diagram that looks like this. So in the second diagram that I have, from here down to this point is 2. So 2 seconds. So this is 2. And from here down to this point is 10. So this is 10. And then the third diagram I have, so this is 3 seconds and this is 10. So for us to be able to calculate our total distance traveled, we have to calculate the area of each one of these shapes. So looking at this, this is a rectangle, this is a rectangle, and this is a trapezium. So we're going to be using the formula for the 2 rectangles and also for that of the trapezium to calculate my total distance traveled. It means that my total distance traveled is area of rectangle plus area of trapezium plus the area of the last rectangle. So that will give me length times breadth plus 1 over 2 a plus b bracket height plus length times breadth. So in the first diagram, the length here is 5. So I have 5 times the breadth there is 4 plus this is 1 over 2. Here I can try to name this part A and this part B. So, and this is my height. So here is height, this is A and this is B. So looking at the diagram, from here down to this place in this diagram is 5. So it means that this part here is 5. So it means I have 5 plus 10, and my height there is what? 2 plus, and this will give me 10 times 3. So this will give me 20 plus 1 over 2 times 15 times 2 plus 30. So it means that I have 20 plus 15 plus 30, and that will give me 65 meters. So the total distance traveled by the object in our question number 1 is 65 meters. Okay, moving on to question number 2. Our question number 2 says a car accelerates from rest at a rate of 2 meters per second square. Accelerate from rest at a rate of 2 meters per second square. So our parameters here, the first parameter that was given is acceleration, A, as 2 meters per second square. And then it said if it travels for 5 seconds, so the time for this travel is 5 seconds. The question says, what is its final velocity? So its final velocity is unknown. And from our formula that we have, we said earlier that our final velocity is equal to u plus at. Now, if you look at in this question, they did not tell us what u is, but it was said in the question without telling us that it is the parameter. Because in the question it said a car accelerates from rest. Whenever an object starts from rest, its initial velocity is 0. So automatically this means that our u is 0 meter per second because the body starts from rest. So if you input our parameters into this formula, it means that my final velocity is equals to 0 plus 2 times 5. This means that my final velocity is equal to 10 meter per second. So that's that on question number 2. Moving on to question number 3. So question number 3 here says a particle moves with an initial velocity of 5 meters per second. So in this question, they gave us the initial velocity u as 5 meters per second. So our u is 5 meters per second. And then it said and accelerates at 3 meters per second square. So our acceleration is 3 meters per second square for a time of 4 seconds. Then it said, what is the distance traveled by the particle during this time? What is the distance traveled by the particle during this time? So if you look at the parameters, it's from the parameters of a question that you tell if you are going to be using the first equation of motion, the second equation of motion, the third or the fourth equation of motion. So we are looking for the distance traveled. So looking at these parameters, you can tell that since you have your initial velocity, you have your acceleration, you have time, and you're looking for the distance, and you're not given final velocity, you use the equation of motion that does not have anything to do with final velocity. And that equation of motion says that distance is equals to ut plus half at squared. This is the only equation of motion that has nothing to do with final velocity. So it means that if I impute my values, it means that my distance traveled is going to give me 5 times 4 plus 1 over 2 times my acceleration, which is 3, times my time, which is 4 or squared. So this will give me 20 plus 1 over 2 times 3 times 16. And this will give me that I have 20 plus 24. And that will give me 44 meters. Okay, moving on to question number 4. It says an object is thrown upward with an initial velocity of 20 meters per second. So our initial velocity u is 20 meters per second. And then it said if it accelerates downwards at, so they've given us our acceleration as 9.8 meters per second square. And because it said it's accelerating downward, so then it said, how high does it go before coming to rest? How high does it go before coming to rest? So we don't know the height. And we know that our height is the same as distance, because in physics, any two quantities that have the same unit are equal. So, and in the question, they said it comes to rest. Whenever an object comes to rest, the final velocity is always 0. So my final velocity is 0 meters per second. So with this, we know that we are using the fourth equation of motion, which says that v squared is equals to u squared plus 2as, which can be rewritten to say that I have V squared is equals to U squared plus 2AH. But because in this question it said that the body is thrown upward, whenever a body is thrown upward, it disobeys the law of gravity. Automatically means that my acceleration here is going to be what? Negative acceleration due to gravity. So with this, it means that I have 0 squared is equals to 20 squared plus 2 times minus 9.8 times height. So this will give me 0 is equals to 400 minus 19.6 height. If I move this to the other side, it means I have 19.6 height is equals to 400. I divide both sides by 19.6 divided by 19.6. This means that my height is equals to 20.4 meters. Okay, moving on from there, we have applications of motion. Motion has numerous applications in various fields. First, motion is applicable in mechanics. So we use motion to design and optimize mechanical systems such as engines, jars, and pulley. So because these systems make use of moving parts, so motion is applied in mechanics to ensure that these parts are constantly moving. And we also apply motion in transportation, like in your cars, in your airplanes, your vehicles that are constantly moving. So motion is applied in this part. We also apply motion in sports to improve what? Athletic performance. During your training sessions, you can decide to jog around the field. That means you are what? Moving. You can even jog on the spot and you are what? Moving. That is what? Application of motion. It is also applied in astronomy. It is used to study celestial bodies as they are moving, as the stars are moving, as the planets are constantly moving. You what? Be able to what? Dictate what kind of object is moving due to its type of motion. Okay, we have come to the end of today's class. Thank you for watching. And if you have any question, drop it in the comment section and we'll reply swiftly. If you are yet to subscribe to the channel, please do, as we'll be dropping the other part of mechanics, and turn on your notifications so that you'll be notified when we drop the last part of this class. Thank you.